Okay, so from 0 to 2, is that going to be a positive or negative integral? Think about it. Come on. From 0 to 2, if I do a cumulative change, thank you, it's going to be positive, right? Because it's just, I'm adding up all these sections here. How about from 2 to 3? 2 to 3 is all negative. So we know this is a negative number. And from 1 to 3, we add and we subtract. So it's going to be less than this alone, okay? So let's figure out in what order can we place them. What is going to be the most, what's going to be the least, and what's going to be in between. And that's really what they're asking here for. Place them in order of greatest to smallest, or in this case, smallest to greatest. So look at the inequality signs. So I'm going to let you guys try to figure out right now which is my smallest, which is my next largest, and which is my biggest. Or maybe just look for the smallest and largest, right? That'll be helpful. So I'm going to let you guys pick which one you think is going to be right, and then we'll do a quick poll in literally like 2 seconds from now. I'm going to stop the video on me. Anymore. Take off my mask too. Freedom. And then I'm going to come on, go faster, go faster, go faster. Okay, here we go. Here's a poll. Oh, darn it. I can't do a poll because stupid. Oh my gosh, in my life. Never mind. I did all this work to do a poll, but then I can't do it. Because I forgot I logged multiple times. Okay, so for this question here, what do you guys think? In the chat, just type in the chat which letter is the answer. Oh, you guys did already. You guys are pretty good. D. Okay, that's it. Let's talk about why. We said this is going to be negative. So that's my smallest right here. Smallest. And then my largest is all positive. So we know this is my largest. And this is guys in the middle. And D does reflect that, right? Oh my gosh.
I can't see all of
it. I know. It's my fault. It's my fault. It's my fault. You're right. And that does look great. Good job. You guys, I guess, process of elimination. Well done, guys. So a lot of times these calculus questions aren't straight math, just straight compute. They're stupid idea questions, which are sometimes harder. Okay. All right, let me go ahead and clear that. Good job. Okay, that's right, D. Let's move on to the next one. Okay, f is a function given by this. Okay, f is 3x squared minus x cubed. What is the average rate of change of f on this closed interval? So careful, it's average rate of change. Average rate of change, not average value. Do you guys remember what the equation for average rate of change is? If you do, please write that down on your notebook right now. If you do not, Google search it quickly. No, don't do that. I'm going to give you the hint. Average rate of change is literally slope. It's just slope, except it's slope from algebra 1. If I give you a graph and I said, here's your graph, what is the average rate of change between points A and point B? Isn't that just slope? So this equation is f of B minus f of A over B minus A. And that's our average rate of change. Okay. So to do this problem, you'd be plugging in what? And plugging in what? You'd be plugging in the 1 and the 5, in this case, 1 and 5, and you would figure out what the y values are and then subtract them. Yeah, see, Gabriel, exactly how I feel.
Sorry.
Okay, so again, this is not a hard problem. This is literally algebra 1. But the problem is because they wrote average rate of change, and if we weren't familiar with that terminology or this idea of average rate of change, we would be totally confused. And we would actually use the wrong problem. We would say, oh, that's the derivative. No, the derivative is not the average rate of change, sucker. Derivative is the actual change at that one point. And that's not average. Okay. Okay, so you guys can take a look here. Which of these answers probably are going to be it. Do you guys want me to move forward, or should I do the problem? Anyone want me to actually do the problem out for you guys while you guys are working on it? Okay, so let's move on to another one. Lena, it is 422. Okay, it's 422 multiple choice. That's the assignment. 422. Okay, let's move on to the next problem. Okay, so let's look at this one. What if the average value of a continuous function of f of the interval is 12? What is this? Okay, what is this? What is that? If the average value of a continuous function of an interval blank is 12, what is that? Okay, now, do you guys remember how to come up with average? Okay. So the idea of average, so I, 100% right now, I'm gonna tell you, I don't know how to do this problem. I haven't seen this in like 15,000 years, okay? But I'm gonna stick with what I know. Average value is this equation, 1 over b minus a, integral from a to b of f of x dx. How do I know that? When you do an integral, this is the sum of all your numbers, and you divide it by the interval, right? By the whatever interval. Okay. So to find the average value of anything, your GPA, you add up all your values and you divide it by the number of things you're dividing by, like your number of periods. Okay. Now, if I plug this in, if it's 1 over 4 minus negative 2, integral from negative 2 to 4 of f of x, okay, dx. So they're asking, take a look here, if I rewrite this, this is 1 over 6. I'm going to rewrite the integral negative 2. 1 over 6, I'm sorry, 1 over 6 to 4 of f of x dx. Okay, that's me simplifying it. I draw the 1 over 6 inside. How is that any different? Oh my gosh, where'd it go? How is that any different from this guy here? How's that any different? Can someone tell me what the difference is between what they want me to find and what I have from the average value?
The constant is different.
Yeah, that's it. Perfect. The constant is different. Good. So this answer here is 12. You guys cool? That answer is 12. So let's get rid of the 6. If I multiply this by 6, 6 times 12 is 72. 4 over, dang it, what am I doing? 4, the integral from negative 2 to 4 of f of x dx is equal to 72. Do you see how we're treating this like just an algebra problem? So how can I get this 1 over 8 of negative 2 to 4 of f of x dx?
Do you just divide by 8?
You just divide by 8. That's exactly it. Because we know this matches this exactly. Like these problems, if I explain it to them and tell you what to do, of course it becomes super easy, right? Oh, is that it? But the problem is when you're taking these questions on a time test and you're stressed, like it becomes difficult. So what did I do to solve this problem? I said, I know what this means. I wrote what that means. Okay. I said, hey, if I simplify it, that kind of looks like that, isn't it? And it turned out if I just got rid of the 1/6, we ended up with that integral that we could keep. So why is calculus important for engineers? Because they do this all the freaking time. Why is calculus important for people who want to become doctors? Because they do this all the freaking time. It's just problem solving. The exact situation may be different, but the fundamentals are still the same. Okay, you guys feeling okay? Look, they even have the number 72 there. Suckers. And if I divide this by 8, we end up with the answer 9. Does anyone have any questions of how I came up with that? Okay. So one thing I want to stress is that for all the problems that we've been doing right now, there have been keywords in each of these problems. In the last problem, we had average rate of change. That's a key word for us. That's slope. And then the previous problem before that, we had the keyword was, hey, look at these integrals. What do these integrals mean? Okay, this wasn't a term, but this was a symbol. So each of these problems, there's something key about it that tells you that's a hint of what to do, at least how to get started. Okay, let's go ahead and clear this and move on to the next one. Okay, this is always ones I hate. I hate these A, B, A, B, A, B, C, A, none. At least they didn't write none of the above here, okay? So remind yourself, which graph right now did they give us? And like, make sure you stress that. Which graph did they give us? Did they give us the original graph? Did they give us the derivative graph? Or did they give us the second derivative graph? And remind yourself, what does F prime mean? F prime is the rate of change. That's a change graph. How much is this changing? Now, before I even look at this, I'm just talking about this. Up here, is the change positive or negative? The change of regular F. The change of regular F is all positive. That's a positive change. I'm growing, I'm growing, I'm growing, I'm growing. I'm not making as much money, sure. I'm growing less, I'm growing less, I'm growing less, I'm growing less. And then I'm starting to lose value. Okay, I'm starting to lose value. So just understand what's going on, the dynamics of what's going on in this graph. Now, the graph of F prime, the derivative of the function F is shown in the figure above. Thank you. Which of the following statements must be true? F is continuous on the open interval from A to B. Is it true that if I have a derivative, that the graph has to be continuous?
Yep.
Yep, seems like it's true, right? Because if I give you a graph that looks like this, that's continuous, perfect, and the derivative exists everywhere. Even if I give you a graph that looks like that, okay, the derivative does not exist there, but it's still continuous. But if I give you a graph that looks like this, right, there is no derivative there. So it has to be continuous. No, it has. If the derivative exists, the graph is continuous. So at least we're seemingly okay there. Is it true that F is decreasing on the open interval? We see that this graph is dropping down. But is this the original graph? It's not. If this was the original graph, sure, we'd be losing value this whole time. But this is the rate of change graph. So what do we say? Are we losing money or gaining money here? We are still gaining, we're still gaining, we're still gaining, we're still gaining, we're still gaining. And not until here do we stop gaining and we start losing money here. So is F, the original function F, is that decreasing over the whole graph? No, we were still making money. So we know this is false. The third one, the graph of F is concave down on open interval. Now, if you want to talk about what's concavity, concavity is the second derivative, right? So it's the derivative of this guy. So what is the rate of change of F prime? What's this derivative? Is the slopes positive or negatives? They're all negative, aren't they? So we would have to agree that we are concave down because all our slopes would have been negative of F prime. Did anyone have a question of how I came up with that? See me okay? Right? And here's the hint, again, it's all back to fundamentals. Before I taught calculus, I'll go to calculus camp, and it was like 6, 7 years, maybe even like 8 years of me going to calculus camp with the school. And I would do calculus once a year. And I would still be able to knock out 90, 95% of the questions. And it's not because I'm smart, it's because I run back to the most basic understanding of calculus as I can. Right? Like what is decreasing, what is increasing? That's the first derivative. Concavity is a second derivative. So that's the reason why, because I'm running back to literally the fundamentals here. And hopefully that's how I'm explaining it. Okay, let's look at the next one. Now on the AP test, you guys have to actually do these questions in like, under like 2-3 minutes each. So that's why the better we are at, oh, sorry, it's explaining again. Sorry, clicked the wrong one. Okay, so going back to the question, darn it, did I close it? Okay, so back to it. Sorry, Jessica, I only read half your question. Okay, so do you want me to explain 1, 2, or 3? Or all
the
of
third
them?
one.
Oh, sure. So Jessica, if you don't mind working with me real quick, what part is concavity? Is concavity the graph, the derivative, or the second derivative?
It wasn't it the second?
Yeah, that's right. And look at the graph here. Did they give me the graph, the first derivative, or the second derivative graph? Which one did they give us?
The first.
First derivative. So how can I get from my first derivative to my second derivative?
Taking a derivative of
Yeah.
it.
And you could take the derivative of it, but remember, what's the idea of a derivative? It's just, what's my fancy word for it? Starts with a C. It's change.
Oh,
Are you okay
yeah.
with that? Right? So do we have a positive change or negative change here?
Negative,
How about here?
negative,
How about here?
negative,
How about here?
negative.
So are you okay that all the derivatives would actually be negative? Because we're constantly changing in a downward way.
Yeah.
So this derivative would actually be, it would look like this. It's a small negative, bigger negative, and small negative. It would actually look like that. Okay.
Okay, yeah.
But here's the problem. People see this and they're like, it's concave up, Mr. Ko, it's concave up. But it's only concave up if it was in the regular graph. Aren't we on the second derivative graph now?
Mm-hmm.
Now, what do second derivatives look for? Oh, sorry, what second derivatives are concavity. So would this be considered concave up or concave down?
Down?
Down, because it's all negative.
Okay.
Because it's less than 0, we know it's concave down.
Okay.
Okay with that?
Yeah.
Now, if we want to go backwards to the original graph, let's feel the waves, okay? The graph is increasing by a lot. Increasing less, and then it stops here, and then it starts to decrease. That's my regular F graph. We have a big increase. We are increasing less. We stop increasing, right? We stop increasing. We hit our max, and then we start to decrease from then on out. Does this?
What is,
yes, go ahead.
Is there like a term for convex?
Or
is it only concave?
Convex and concave refer to like different things. Like one is going up and one going down. Yeah, but we just say concavity. Like
okay.
Convex, I feel like that when you think of a lens, like convex or
Yeah.
concave refer to lenses. Yeah, but in calculus, I think we just talk about it as concavity.
Okay.
Concave up or concave down. Is that a little bit better? Does that make sense?
So if it was concave up, then it would be positive.
It would. The graph would be going this way because we're constantly increasing. So the graph would be up here.
Oh, okay. So it's just asking if it's decreasing or increasing.
Right. Because that's what derivative means. It's increasing and decreasing. And if it's decreasing, we know its derivative is all going to be negative. And for us, if the values are negative in my second derivative, that's concave down.
Gotcha.
Cool. See, it's all back to the basics. It's really back to the basics. That's why we're refreshing ourselves because we haven't seen this in a while. Okay, let's do the next Now this one looks hard. It looks like, oh my gosh, Mr. Ko, why are you trying to, why you hate us so much? And what did I write in my comments here for this question? This was number 6. If you look at number 6, I wrote super easy, like super easy. Okay, what's f prime?
Isn't it just fundamental theorem of calculus?
Yeah, it is. Thank you for remembering that. So if you remember this,
Easiest one.
it's like the easiest one in the world. So, right. So they gave us f, okay? They want, for which of the following expressions is f prime? So doesn't a derivative cancel out this integral, essentially? That's not the way I explained it before. All you do is just plug it in. Now, there is no chain rule because that's just x, the derivative of x is just 1, so there is no chain rule part of it. And a lot of people might have thought, hey, the derivative, the 1 goes away. But if you remember fundamental theorem of calculus, you just plug it in. Do not do anything else. You plug it in. And there's only one answer here that fits that. Now, if I had changed this, so let me give you a change here. If I wrote f of x is equal to the integral of 3 of 2x tan 5t secant 5t minus 1, okay? If you remember, this is when we need chain rule. You would plug it in, it would be tangent, 5 times 2 is 10, secant, 5 times 2 is 10, minus 1, and then we'd multiply this by a 2 because of chain rule. Okay. Some people, the reason why they wrote this is some people said, hey, isn't secant tangent, the integral of secant tangent, isn't that secant? And they took the integral and they tried to go backwards. And again, it's about reading the question, catching what that stupid hint is. What's the clue here? I'm going back to our rule and remembering it. Hey there. Okay. Let's go to the next one. Anyone have a question about this one? Feeling okay?
Wait, so what would the final answer for this one?
Come on! Don't ask me. I just literally just taught it. What do you think it is? Why don't you give me a guess?
C or D?
Okay, C or D. Okay, at least you got close. Now, if you remember the fundamental theorem, fundamental theorem of calculus here. If I take the derivative of an integral, we just said we just plug it in. Do we say we take the derivative of this? No, we just plug it in. So it would be D. That's right, Jessica, it would be D. And even though you don't want to say it's D, because you think you have to do something with that stupid 1, but you don't. We're just plugging it in. Okay. Because, okay, if I did take the integral, wouldn't that have become T? And then wouldn't you plug in X and then take the derivative of X and we could just go back to 1? That's really what would have happened. Okay, so this question is kind of stupid, but I know that some of you guys are going to mess up because of chain rule, so I'll let you guys do this a little later, okay? I'm going to do 2 more questions, and then I'll let you guys off. Okay, so this one here, this one is, oh my gosh. When you see this question, you're like, I don't want to do limits. I hate limits. But I want to remind you that this is actually the definition of a limit. Sorry, a definition of a derivative. This is a definition of a derivative. We had 2 ways of writing a derivative before. We had the limit as x approaches 0, and we write that the limit as h approaches 0, I'm sorry, of f of x plus h minus f of x all over h. And we had a second way of writing a limit as h approach, sorry, not h, as x approaches a of f of x minus f of a over x minus a. And both of these were fancy way of writing f of x2 minus f of x1 over x2 minus x1, which is just slope. Okay. So I want you guys, even if you did forget this, if you plugged in 3 here and you plugged in 3 here, isn't f of 3 minus f of 3 just the same point, same y point? And isn't 3 minus 3 the same x point? But you're taking the rise over run. This is just slope. And folks, what's a big calculus idea for slope? You guys remember? That's just the derivative. Okay, which is 1 over x. You want to find the derivative at 3. This is why this problem should take you like 30 seconds. And that's why they expect you for the calculus test, like to be able to solve questions under like 2-3 minutes, because you'll be able to do the easy questions quickly and the long questions you can spend more time on, right? Do you guys kind of remember this as the derivative equation, our slow way of taking the derivative way back when? And then we learned power rule, like, oh, power rule, that's so much easier. We should have just did that, Mr. Ko. Why'd you make us do limits? Okay. All right, let's move on to our next question. Okay, this one, next question is, if you look at it, it's just what? It's just take the derivative. So you see a quotient, you just have to remember to do quotient rule. Okay, 10. 10 is a beautiful question. Oh my gosh. I used to get stuck on these. I'm like, why? Now, I'm going to walk you through this. So this last question I'm going to go through, and then if you want me to do 1 or 2 more, let me know, okay? But this question is a beautiful, terrible question that gets suckers like me all the time. So let's take a look. Left graph, this is f. This is what f looks like. Right graph, this is what g looks like. Great. So let's see which of these statements will be true. Which of these statements will be true? Oh, sorry, which statement is false? The graph of the function f and g are shown in the figure above. Which of the following statements is false? I want you guys to go ahead and read through these and tell me which one are you not sure about. Okay? A, B, C, or D. Once you go through them, tell me which one you're not sure about. And you can be not sure about a couple of these. And just go type them in the chat. Which of these you're not sure about? Is it true? A, that the limit of f as we approach 1 is 0. Is that true? Is that true? Okay. Again, is the limit as we approach 1. Okay, 1's right here. 1's right here. Is it true that the limit is 0? Now, if you forget what limits are, I say, what should it look like? Not what it is, what should it look like? Does it look like the y value at 1 is 0? That should be yes, it does look like 0. Can you tell me in B, as we approach the number 2, here's 2, can you tell me that the left side and right side agree that it looks like a number? Your dad says 1, your mom says -1. Doesn't look like anything, right? Does not exist. I will say this is also true. These are both easy. Those are both true. Look at 3, and you're like, okay, just plug it in. We should just plug it in. Let's just plug it in. If I plug in 1 here, f of 1, isn't that just 0? Didn't we just say it's 0? And if I plug in 1 here, isn't it 1 plus 1, 2? Hey, that doesn't exist. What is 0 times does not exist? Yep, does not exist. Shouldn't 0 times does not exist? Shouldn't it be does not exist? That looks right. Yeah, that looks right. Okay. But that was my problem. Let's go and do the last one and see that that one's true or not, okay? If I plug in 1 here, that's f of 2. F of 2 times g of 1. Do we have any problems with f of 2? Do we have any problems with g of 1? That just exists, right? That's easy. Those are real numbers. So they all seem freaking right. But which one was the one that was kind of funny to us? Would you guys be okay that C was the one that's kind of funny to us?
Yeah.
Now here's the reason why. What I did was wrong. If I plugged it in, of course, it looks like 0 times does not exist. Instead, I want to show you this. Why don't we take a step back? And instead, look at this. When I choose f of 1, okay, what's the limit? What's the limit from the left side as x approaches 1 from the left side of f of x and g of x plus 1? What would happen if I looked at the left side here? Isn't that number really close to 0? And what's a number really close to 0 times 1? See how I'm really close to 0? Everyone take a look here. I'm really close to my problem. So what is really close to 0 times 1 look like? 0.
Very small decimal.
Right. Can we just say that's 0 because it gets close to 0?
Yeah.
On the right side now, please everyone take a look at the right side. If I did the same thing from the right side, because that's what the limit is, from the right side, that's really close to 0 too, right? Isn't this just negative 1? What's really close to 0 times negative 1?
Also 0.
Also 0. So what's the limit actually? Does it really not exist? The limit is
0.
0. Stupid question. Like, honestly, like, you go through this and you spend 5 minutes thinking they're all real, they all exist, these are all true statements. But when we remember what a limit is, it's on the left side and on the right side, and do they agree? On the left side and on the right side, do they agree? And they did agree. They both equaled 0. Stupid question. And that's why this could be frustrating sometimes. It's like, yeah, you got this right. You got like all this right, except that last one, which was our tricky one. And it's because we didn't take that next step to verify it. Okay, so these are some of the tricks where, hey, it doesn't make sense. Maybe I have to break down the question some more and look at it from a different perspective. Now, hopefully you guys have all these skills that we've been working with already. You might have forgotten a little bit about them, but hopefully you have most of these skills. Okay, all right, so the rest of it, I have notes for you guys. You guys take a look at it. If you guys do get stuck on it, please let me know. I will answer you, and then I'll post the answer onto the homework page as just another picture that you guys take a look at, okay? Besides that, if you guys have problems with Lockdown Browser, let me know. I'm going to try looking for a video to help you guys install that if you guys haven't done so yet. And make sure you guys can do Lockdown Browser. I will talk to you guys on Tuesday next week, okay?
Mr. Ko, we just have to have this done by Tuesday, correct?
Yeah, right. Because I needed to give you guys a deadline, because if not, you're not going to do it. And because I'm going to give you more questions, so it's going to build up quick. Yeah, I get it. But yeah. Okay. Anyways, see you guys.
Thank you, Mr. Ko. Have a
Bye.
good
Bye.
Hi, Mr. Ko.
Bye, folks. Hopefully you found this fun.
Mr. Ko, what about the other assignment on God's work?
No, don't do any of those. I just do this one.
Okay.
Just so I was trying to play with it. That's why. So I gave too many, but only do the ones I assign on Schoology. Okay. Thank you.